Okay, the topic given is on the requirements of complex problem solving, WP. Okay, in terms of the content, most likely I will spend around 50 minutes to go through the slides, and I have roughly about 50 slides, but effective slides are only 41. Okay, in terms of the introduction, engineering accreditation requirements, all of us are already aware that the requirements by the Engineering Accreditation Council, Board of Engineers Malaysia, through Engineering Program Accreditation Standard 2020. So this is the latest one, and all of us have already gone through the process of accreditation year 2018, and we just recently received our results for interim. Alhamdulillah, I think all programs has already managed to go through the interim. So we have another 2 years or 3 years before we will face the next cycle of accreditation. Okay, in terms of the terminologies used by engineering accreditation department, right? We use the same terminology stated by or used by Washington Accord. The Washington Accord, it is a accord that being signed through the International Engineering Alliance. So Malaysia since 2007 have already become a signatory member for Washington Accord. That's why we have to follow the international standards for engineering education. So in terms of the terminologies used by Washington Accord, that includes complex problem solving, WP, meaning that whatever we are using the definition at the Board of Engineers Malaysia are the same that being used throughout the world, especially those Washington Accord signatory countries. I think more than 30 countries already become a signatory. And in the term of complex engineering activities, EA, I believe the complex engineering activities will be covered in the next webinar series. So we will be focusing more on the complex problem solving for today's session. And WK is a knowledge profile, and WA are the graduate attributes or the program outcomes. So most of us are already aware, and I just want to highlight that the term being used, WP, EA, WK, and WA are the short form that we are going to use again and again throughout this session. Okay, a little bit on the knowledge profile. I just want to touch it a little bit before we go into the complex engineering problem. What is knowledge profile? Basically, knowledge profile are the broad characteristics of different components of the knowledge embodied in a program. So we have, as being spelled out by Prof Aliani last week, with regards to the program outcomes, it is interrelated or closely related to the knowledge profile. So basically, knowledge profile is to provide additional guidance on curriculum design and curriculum review. Okay. Okay. So basically, in terms of the conceptual, why knowledge profile is being used. So if we look at knowledge profile elements, we have WK1 until WK7 as stated in front of you now. So WK1 talking about natural sciences, WK2 mathematics, WK3 engineering fundamentals, WK4 are specialist knowledge in terms of, let's say, is it an aerospace program, is it agriculture program, or chemical engineering, and so those are being stated in WK4. And it is interdependent, meaning that WK4, the specialist knowledge, is built on the engineering fundamentals. So the engineering fundamental we are talking about, it cut across all programs. The basic engineering knowledge that are required throughout the programs, and which is also rely on the natural sciences, the fundamental of physics and sciences. And all of these are relying on the mathematics. It is being supported or being governed by the mathematics background. In terms of that is the knowledge, the conceptual knowledge, contextual knowledge in terms of the application of knowledge that we stated WK5, which is related to the engineering design, WK6 related to engineering practice, and WK7 related to comprehension of the role of engineering in society and identify issues in engineering practice. So later on, we will look at how these knowledge profile map to the complex engineering problems. Okay, the program outcomes, when we use program outcome, which describes what students are expected to know and be able to perform or attain by the time of graduation, because we are preparing the graduates to become workers, to become engineers. So whatever we promise to the students are the program outcomes that we should deliver and should be able to be attained by the students upon graduation. So these relate to the skills, knowledge, and behavior that the student acquired through the programs. Okay, so the program outcome itself is a components indicative of the graduate's potential to acquire. So we have PO1 until PO12 as stated in the EAC manual, are the competence to practice at the appropriate level. So basically, we are preparing our graduates to be prepared to go into the industry, to go into the working environments. Okay. Right. This is a summary of the knowledge profile which already being stated earlier. Okay, I have explained WA1 until WA7 just now. Okay, and we also have WA8, which is the ethics, and all of these WA1 until WA8 are considered as can be addressing the complex problem solving. Meanwhile, the WA9 until WA12, the program outcomes or graduate attributes number 9 until number 12 are or can be addressed through the complex engineering activities, right? So if we look carefully here, WA1 to WA5, the program outcome 1 until 5 can be addressed through the knowledge profile WK1 until WK8. We have WK5 as well as WK6, which is basically in terms of the analysis of problems and synthesis of solutions, where WK7, which is including the program outcome 6 until 8, it involves responsibilities. If we look here, engineers and society, environment and sustainability, as well as ethics, and required in workplace that is being covered under program outcome number 9 till 12, teamwork, communication, project management and finance, and lifelong learning, right? So in terms of the summary of the program outcome, so basically the analysis of problems and synthesis of solutions based on engineering knowledge supported by engineering tools, techniques, and methods. So we have the engineering knowledge, we have modern engineering tools, which involve in problem analysis that involve design and investigation, whereby this is the WA1 until WA6 just now. Responsibilities of engineering practice with regard to social, economic, cultural, health, safety, regulatory, environmental, and sustainability issues. Okay, ethical responsibilities of engineering practitioners is covered under WK7, engineers and society, environment and sustainability, and ethics, basically PO 6, 7, and 8. And finally, individual attributes that are essential in the engineering workplace that include effectiveness as individual and in teams, communication, engineering management, and independent learning. So as a whole, all of these program outcomes have to be delivered throughout our individual programs. So this is the graduate attributes. Probably I would not go into detail. I believe Prof. Aliani has already discussed in detail and explained all of the component of PO1 until PO12. And let us go to the main for today, which is the complex problem solving. All right. Before we go any further, probably all of you that has already gone through examination. We have already conducted examination. For those who are new, probably this is the first semester that you are going to conduct examination. And in examination or the assessment, you have to figure out what are the contribution or what kind of elements of complex problem solving that you are going to use. Basically, there is a mapping already being introduced at the faculty, which respect to the complex problem solving, the WPs, as well as the WK, the knowledge profile. So later on, I'm going to share with you which WP will be mapped into WK. So, but before we go into that, we may want to look into the definition of each one of the complex problem solving, or known as WP. So we have 7 WP, all right? We have a WP1, which talk about depth of knowledge required, all right? This is the looking into the program itself. Let's say it is if it is mechanical, so depth of knowledge in mechanical field, right? And then WP2, range of conflicting requirements. WP3, depth of analysis required. WP4, familiarity of issues. WP5, extent of applicable codes. WP6, extent of stakeholder and level of conflicting requirement. And finally, WP7, interdependence, right? So in your moderation form, when you want to prepare for your examination, you are being asked to declare which WPs that your particular course or the assessment going to address. So basically, let's us just look at what are the definition all about. So in terms of the attributes, basically during the examination, you have to choose not just one WP. It is a requirement by the EAC saying that you have, if your particular assessment having to address complex problem solving, meaning that you have to have the element of WP1, and WP1 is compulsory, and it's stated there in page B5 in the standard. You need to have WP1 and some or all of WP2 to WP7. What does that mean? It means that you need to have WP1, check, and another 2 WP minimum, either WP1, WP2, and WP3, or a combination of the rest, WP1 with another 2 WPs. Right, let us look into the attributes, and what do we mean by WP1? When we talk about depth of knowledge required, it means that any problem that cannot be resolved without in-depth engineering knowledge at the level of 1 or more knowledge profile 3, 4, 5, 6, or 8. Okay. Which allows a fundamental based first principle analytical approach, right? So it is quite straightforward to be addressed in any of complex problem assessment. So it is not straightforward. It cannot be resolved without in-depth engineering knowledge. So you know better in terms of what do we mean by without in-depth engineering knowledge, meaning that the student when you being introduced or having a question, it is not just straightforward. It is not just using an equation saying that to solve a problem, just use this equation, you get the result, right? So this the question has to be crafted in terms of it has a few layers of steps in order to be to get the right answer. So it is not just straight away putting numbers in equations and the student will get the answer. So that is complex enough. So probably the student has to make assumptions, provide justification why they use certain approach in order for them to solve the problem. Right? Probably it is going to be clear. It's going to be much clearer when we look at the examples later on. And then what is WP2? Range of conflicting requirements. So it has to involve wide-ranging or conflicting technical, engineering, or other issues, right? So it's not just looking into one side of the story. There must be a range of conflicting requirements. Probably a best example may be requirements if you are looking at a building a retaining wall for civil engineering, for example. So what are the requirements by the Jabatan Alam Sekitar? What are the requirements by Jabatan Parit dan Saliran? Maybe requirements from other authorities that allows you to finally come up with the solution for the problem. So it can be, it is very, very open-ended, meaning that it can be, that is what we meant by range of conflicting requirements. And then if we look at WP3, depth of analysis required. If you look carefully, WP1 and WP3, depth of knowledge required. And then the keyword here, the difference is the depth of analysis. And depth of analysis required. What do we mean by that? Is that the question or the problem have no obvious solution. It's not straightforward. Okay, so it requires abstract thinking, originality in analysis to formulate suitable models. It is not the norm. It's out of the norm. It's not something that happen every day. It is something that are special. All right. So for example, we can build a house in Malaysia, for example, and then what are the requirements if we want to build a house on the moon or on Mars? Okay, which requires different set of parameters, different solution to it. It's not straightforward. Putting a foundation, piling, and so on. So there are other consideration need to be taken. So there is quite some example that you can look at. So compared to WP1 just now, the knowledge required, and WP3, the analysis required, depth of analysis required. We want most likely you will have this through, you can have it through examination. Okay, you can also have it most likely through projects. Quite easy to handle or to be addressed through project rather than through examination. Examination, most likely you can have WP1 straight away, but WP3, depth of analysis required, most likely you need a project for the student in order for them to address this WP3. And then what is WP4? Familiarity of issues. It involves infrequently encountered issues. So issues that are not frequently happen. Maybe nowadays we have flood problems. So it is not frequently happen. Of course, every year flood happen, right? But it's not every day you have floods in the situation. So this is a problem that you can address WP4. And then WP5, extent of applicable codes. What we meant here is whatever outside problems encompassed by standards and codes of practice for professional engineering. So let's say you have standards that you normally use to design product or provide solutions, right? So WP5 requires something outside the standards, so outside the available code of practice for professional engineering. So this is quite tricky, and you need to find ways how are you going to address this particular WP. Of course, this is a complex problem. This is not something that are within the standards, within the applicable standards or codes or regulations that are available. Okay, and WP6 is basically extent of stakeholders' involvement and level of conflicting requirements. So what do we want here is basically we want to see whether there is involvement of diverse groups of stakeholders with widely varying needs. So when you want to involve programs, for example, I think I addressed this through Engineers and Society, where a student can engage the community. There is a requirement by the society, the community. There are requirements by the stakeholders, for example, the PBTs, and maybe governments and so on. So many more diverse group means more than one or more than two stakeholders involvement in any of the problems that you are handling. Okay, so that can easily addressing WP6. And finally, WP7, interdependence. Okay, so what do we want here? We want to see there are high level problems including many component parts or sub problem. So if you imagine you have exam questions, you prepare an exam question, you have part 1, okay, part A, for example, student has to address finding certain numbers and values that are required to be used in the part B question, as well as part C if you have more than 3 parts, right? So it is like a long question. So it's not straightforward. There are many components that are required. So you have to show that in order for you to address WP7, you need to have asked the student to find certain values that are going to be used later on in the following questions. So that is what we meant by WP7. So overall, in any of your complex problem solving questions or assessment, you need to have WP1 and a combination of another 2. All right. So I believe the faculty has already come up with the combination, and let us see later on what are the mapping between WP1, WPs and the knowledge profile. Okay, before we look into that, maybe it's best to look at the characteristics. Just now I already explained in general what do we mean, what are the requirements by EAC in terms of the WP through the definition. Okay, so let us strengthen. This is taken by from an article by Pang et al. 2016. When we say complex engineering problem, all right. So it is difficult to the solver, all right. So maybe it is difficult to the solver, difficult to the student. Maybe it's easy to you or easy to be solved by certain level of people, but it is difficult to the people who want to solve it. It is unfamiliar, okay, has not a number of variables and parameters that need to be considered. Okay, it is also connected to few parts of a system or a few different systems, right? Interdependent. Say you need to solve ask the student to solve a certain part of the question, and then it has to be used to solve another part of the question. So the solver does not have immediate solution to the problem. By looking at it, it has to have level of difficulties, level of steps in order for them to find a solution. The solver need to define the problem, right? To state the boundary, the what we call it as the assumptions, in order for them to address the problem. Okay, the solver or the student need also to develop his or her justification for the solution. So they have to be able to give justification, give reasons why they think this solution is best for the problem. Okay, that's being taken by this article. All right, and then a complex problem also need to think broadly, okay, and systematically, and see the big picture when you want to approach a complex problem. And it is a difficult decision, uncertain strategies, confusing idea, contentious product, and intractable change. Those are kind of the elements of a complex problem. When we talk about complex problem, we cannot run away with difficulty and uncertainty. So when we look at this, we can say that yes, we have to really look what do we mean by complexity, right? Complexity means the problem contains a large number of diverse, dynamic, and interdependent elements. So maybe you feel that, oh, it's already complex, but on the other side, the moderator, the person who moderate your question paper, when they look at the solutions, it is not complex. So those kind of things, it has to be balanced. So meaning that when it is complex, so the solution to it also has to reflect on the complexity. And measurement, is it difficult or practically unfeasible to get good qualitative data, and maybe through projects, maybe through lab activities, so we can get this kind of complex in terms of the measurement. And do we require novelty, right, in complex problem solving? Of course, maybe not through examination, maybe through final year project, maybe through IDPs, there will be some kind of novelty, some new solution or new approach, and new product can be become the outcome, or an innovative design is needed, right? So that is another way to look at complex problem. In other words, complex problem is basically a combination of a scientific or technical problem. You can have a scientific problems which are not complex. You can have a technical problem which are not complex, but a combination of it, a scientific, technical problem, combine it together, and it become a complex problem. So this is just a philosophy behind it. The characteristic of technical problem when we compare to complex problem. So we have a table here. It's not exhaustive. Probably you have a much more clearer definition on the differentiation between a technical problems and a complex problem. All right. So let us go through one by one over here. We have a technical problem that can be isolatable. It can be isolated, right? Whereas a complex problem, most likely there's no definitive problem boundary, but the solver, the student, need to define the boundary of the problem themselves. Technical problem is universally similar type, whereas complex problem are relatively unique and unprecedented. Right? Technical problems are normally stable or predictable problem parameters, whereas a complex problem, you may face unstable or unpredictable problem parameters. Okay, a technical problem has multiple low-risk experiments which are possible. However, a complex problem may have multiple experiments which are not possible. Limited set of alternative solution may be addressed through complex technical problem, whereas no bounded set of alternative solution can be used for complex problem, right? And then a technical problem involve few or homogeneous stakeholders, whereas complex problem may involve multiple stakeholders with different views as well as different interests. A technical problem has a single optimal or testable solution. Complex problem, there are no single optimal or objectively testable solution. What does that mean? Is that it's best to be addressed through open-ended questions. So there's no definitive solution for a problem. It depends on the assumption, it depends on the approach, it depends on the data presented by the solver, by the students. Okay, and a technical problem also, a single optimal solution can be clearly recognized, whereas a complex problem, no clear stepping point. But of course, we can teach our student in terms of what are the best approach to address complex problem. Right. How do we design complex engineering problems? This is taken also from the paper by Pang et al., Perception of Complex Engineering Problem Solving Among Engineering Educators. There are many approaches, I think is also happened here. Okay, for example, like respondent C saying that the questions are integrations from several topics. That's why it is called or it is declared as a complex problem. Another respondent saying that it is related to the syllabus. We never teach before, but provide handout or give short briefing about the project. So the students need to find out on their own, go for an interview and learn how to get information from other people. The students are out of the comfort zone. Okay, so this is another respondent saying how they define or design complex engineering problems. All right. And then another person say that I did like C, having integration from several topics, and I related all the topics while teaching a subject. Okay, so that's how E done it. Another person, so far it is difficult to design a complex problem in examination paper for year 1, for example, because the lessons are very fundamental and not specific. This is just an excuse saying that year 1 student should not have complex engineering problem, so which is not true. So you can have complex engineering problem from year 1. So you have to be creative enough to craft a question. Another person here, I design complex problem in a case study because it is open-ended, right? Students create the problem, think independently, measure and find their own solution, right? They need to identify the problem first, right? Problem-based studies or problem-based learning or case study. Another one here, the task is more on complex activity. Consortium to solve problem, must integrate to find the result and involve more integration activities. And another person saying that each of the level has their own complex problem. And final exam is not suitable to design complex problem because complex problem consume time and lots of discussion. Yes, yes and no. And some depends on the situation. I think we have many experience putting down complex problem in final exam question. Okay, example here. Okay, this is a slide from, I think, from Dr. Salah when we did our workshop back in 2019. Question on chemical engineering, right? Sungai Melana is a small river flowing through several residential areas in Skudai. So you are a consultant appointed to propose a river restoration action plan. Okay, so you have to put up your proposal, how to improve the water quality, prevention of direct solid waste discharge, creating suitable habitats, adding property and aesthetic value. So basically, this is an example of exam question that is actually a complex problem. Another example here, okay, taking from civil engineering. I think this is from Engineer Azlan. 2 villages in a country called Timbuktu, which are separated from each other by a valley. Okay, and then the valley is dry all year round, and they create the situation over there. putting them some information about the soil, all right? And you need to write a project brief on how would you approach to design for the replacement bridge. So you are limited in terms of the building materials, and heavy equipment is not available. So by creating such situation, you are asking the student to explore solutions. There's no right or wrong. They have to put up their justification, how they are going to solve the problem in this particular situation. Okay, this is an assignment for civil engineering student. And what is important here, this is also, if we look at integrated design projects, where most of us are having this IDP from EAC perspective, and IDP shall involve complex engineering problems and design systems, components or processes integrating, culminating core areas and meeting specific needs. Okay, that includes public health, safety, cultural, societal, project management, economy, and environment. Right. So for those who are taking or delivering into IDP, you are very familiar with this. So I just want to show how we did it in the department. So if we look here, right, how the requirements by the EAC manual for IDP can be translated into our own program outcomes. We have PO3 over there, complex engineering problems, PO12, project management, economy, PO13, working in group, PO11. Right, if you look at the syllabus, right, I think this is quite familiar to those who are teaching IDPs. Okay, it's clearly stated in the learning outcomes and also the synopsis. And if we look at the mapping between the requirements of our integrated design project from EAC and our engineering curriculum. So if we look here where an IDP course are required to address so many program outcomes, I think around 8 program outcomes from PO1, PO3, 6, 9, 11, 12, 13, and 10. Maybe it's already being revised. This is based on 2019 curriculum. And then looking at the knowledge profile, okay, so we have WK1 until 4 to address PO1, WK5 to address PO3, designing solutions, and WK6, knowledge profile to address PO6. Okay, if we look at the complex engineering problems as well as complex engineering activities requirement, where we have already mapped WP1 and WP3 for the engineering knowledge, map against 1 to 4, WK knowledge profile 1 to 4, as well as WP1 and WP6 to WK5, the knowledge profile number 5. So if we look here, WP1, WP3, and WP6 are required to be addressed in the IDP. This is what we have already agreed at the faculty level. Whenever you want to address IDP, okay, integrated design project, it is already being mapped to the knowledge profile. Okay, and of course, engineering activities, which is not being covered in this particular presentation, is addressing the communication aspect. In terms of the mapping, right, probably I can skip this one, the domain, PO/CO domain distribution, right? And how do we assess our IDP students? Thank you, Dr. Salah, for this particular slide. Designing solution, engineering knowledge, project management, modern tools usage, communication, individual and teamwork, entrepreneurship, ethics. So whether we can address it through presentation, we can address it through report, product, or examination.
Yeah. Start from here.
Okay, the PO assessment, this is what we did in way back 2019. Maybe it has already been improved by Dr. Salah for the current process for IDP. So previously we have proposal, logbook, minutes of meeting, how we look at ethics. This is an examination, right? Interview, we have interview session, presentation, report, and product demo. This is how we break out in terms of the distribution for the marks. For the complex problem solving approach, the aspects of economics, social, environment, ethics, management, technology analysis, and evaluation are taken into consideration for the this is, I'm talking about the integrated design project, IDP. Where when we look at the complex problem solving approach thinking, right? So we have a student has to look at the site condition, weather, available technology, building material, design, costing, and scheduling in order for them to solve the problem and the approach to solve the problems. In terms of the solution, okay, of course, a student can look into problem-solving skills. There are many approach for problem-solving skills. They can also formulate the problem. They can also look at literatures, whether there are similar cases happening before. They can also conduct experiments and simulation whenever they want to find solution for complex problem solving. Right? In terms of assessment, this is just an example. It can be report style, display by presentation. You can have a presentation, viva, or interview. Okay, you have teamwork and as well as management scheduling. So in summary, I think we are going into the last 10 minutes. Let me just go through the summary of today's presentation. Probably there are questions and opinion can be taken from the participants later on. If we look at the outcome-based education curricula, right, the curriculum shall provide students with ample opportunities for analytical, critical, constructive, creative thinking, evidence-based decision making in dealings with complex problem solving. Right, so our curriculum has to reflect that. Whatever it is, it has to contain complex problem-solving elements. If not, it is not an engineering curriculum anymore, right? It's going to be engineering technology curriculum, most likely, right? And the curriculum shall include sufficient elements for training students in rational thinking and research method, all right? And how does complexity relate to curriculum? Okay, it can be related to the general courses. It can also go into the industrial placement. So we have latihan industry. We can also have be addressed through core and specialist engineering courses. This is a quite common to address complex problem solving. It can also be addressed through elective courses. Most likely, the complex problem solving are being addressed heavily in elective courses. Of course, we have design project and final year project. Okay. Not to forget, complex engineering problems can also or need to be addressed through laboratory activities. Is when we say laboratory activities, meaning that we have to introduce. It is compulsory to have lab activities which are open-ended. So throughout the program, maybe you have laboratory 1 until laboratory 3. So you may need 1 or 2 elements to become complex problem solving. So there should be adequate provision for laboratory or similar investigative work which will develop in the future engineer. So because the purpose of training student to how to approach complex problem solving, because we are looking at engineers to solve future problem, because we are not train them to solve current problem, because they are going to face future problems which are not happening today. Throughout industrial training, this is about complex engineering activities. Okay, so probably it's best to address the complex engineering activities rather than complex engineering problems. Okay, and as I already highlighted earlier, complex engineering problem solving can also be addressed through IDP, and it has to meet the needs for consideration for all these elements. And self-assessment report for EAC and also require the program owner to report how the complex engineering problems to be addressed in the program. Okay, before I end, this is just a mapping being prepared by, I think this is a presentation by Professor Aliani, showing how the program outcomes, the knowledge profile, EAC 1, EAC 2, and so on, that is being mapped to the appropriate knowledge profile. And we also propose the complex problem solving at WP1 plus WP3 and 7. Let's say your course is addressing EAC 1, so you may want to use WP3 and WP7. Okay, and if you are teaching engineers and society, this semester I'm teaching engineers and society, so I have to address WP5 and WP6, which is quite tricky. WP5 is the codes and standards, so how to find a problem that are beyond the codes and standards. Okay, so that is already being mapped by the faculty of engineering. So I think now it's quite straightforward, whereby you can follow the suggestion made. If you are doing using modern tool, you address WP3 and WP7 and so on. Okay, so with that, probably it's best to acknowledge the references that I've been using to compile, to prepare the presentation. Thank you very much to Engineer Abdul Aziz, and then Professor Aliani Ismail, Dr. Ahmad Salahuddin, and then of course Prof. Nukamar and Nordin for sharing their presentation for me to prepare this presentation. So with that, thank you very much. Maybe I pass back to the moderator, Dr. Yazdi, to handle the Q&A. Yes, Dr. Yazdi, please.
Yes, thank you very much, Prof. Thank you for the speakers. I think we could gain certain information and clarifications in terms on how can we employ these WP in our assessment. Right. So basically, if you have any questions to all the audience, you can leave a question in the chat box, or you can unmute yourself, ask a question to the speakers, and anybody can join as well. We can make it as a forum. So before that, I think I just have I have a few questions, not few questions. I just wanted to Prof say something about it. Okay, what is W? Okay. So what is W? Okay, WP, WK. So what is W? It is W over there, right? And then does all the WPs need to be sufficiently covered throughout the program? Is it a must for all the WP to be covered throughout the program, right? And okay, you may start with that.
Okay, thank you very much, Dr. Yazdi. I think he knows the answer.
I know the answer.
Just nak memanas badan untuk yang lain. Yes, W. Why W? Why the letter W? Why WA, WP, WK? If you look at the IEA, the documentation for Washington Accord, documentation for Sydney Accord, documentation for Dublin Accord, so they take the first letter. W means Washington. Okay, Washington Accord for the knowledge profile, Washington Accord for the problem solving, Washington Accord for the attributes, and WA, WK, WP. So if it is Sydney Accord for Engineering Technologies program, so they use the letter S. So if it is for the technician program, they use the letter D, Dublin Accord. So there's the answer. Maybe some of us doesn't know about it. These are the answer. So YW, YS, YD. And the other question by Dr. Yazdi just now, with regards to addressing the WPs. We have 7 WPs, WP1 until WP7. Of course, a particular program need to be able to show that all the WPs are successfully being addressed. Meaning that we have 140 credits curriculum. Ada berapa, Yazdi? 140? Okay, so throughout the courses, we have to ensure all the WPs has been addressed. Okay, so the mapping that I've shown just now that has already been proposed by the faculty, okay, are already addressing all the WPs, meaning that if your course are required to do investigation, so you just follow WP that are being proposed, and we can easily say that the course as well as the program has already fulfilled all the WPs. If everybody cooperates to address all the WPs. So not necessarily just one person or one particular course addressing all the WPs. Pengsan lah kita nak buat semua, especially IDP. So IDP, there are many WPs, there are many WK, but we put up only 3 WP, WP1, WP3 and WP6. So engineer and society, WP1, WP5 and WP6. So if we map carefully all of the courses, we have to ensure all the WPs has been addressed. And normally during the accreditation exercise, maybe in 2024, in the future, we have to prepare the what we call it as the WP's kita panggil box Yazdi
Yeah.
So the example how
box.
WP1 be addressed, how WP5 being addressed, through which courses. Yang tu apa ni EAC panel would be very happy if you can show that it is being addressed not just through one course. So that's easy. Maybe there are other opinions from members who are, I think kita ada Prof No, our Associate Director of EAC, EAD, maybe she has a better answer for that.
So we can say that, so it is a compulsory for all the WPs to be addressed throughout the programs, right? So I have a question from Hamba Allah. Oh yes.
I think Dr. Farah ada question.
Okay, Dr. Farah next, because Dr. Farah, please you can go ahead first.
Okay, nak tanya WP ni problems ni is bukan kita assess kan, kita kena jalankan dalam membuat kita punya assignment ataupun kita punya examination kan, kita bukan assess kan. Dia dalam proses tu mesti ada elemen-elemen tu, betul?
Betul. So maknanya yes, thank you Dr. Farah. Yes, let's say you want to address WP di dalam exam question. So normally dalam exam question kita declare it is WP1 for example. Maybe another exercise or assignment it address WP6 and WP5 for example. So it is not assessing the WP. It is how you it is the elements are being addressed. Contohnya macam WP5 tadi pasal beyond codes, coding ataupun standards. Maknanya kita kena tunjukkanlah yang masalah tersebut, soalan tersebut boleh address. Macam itulah. Maknanya we should be able to defend yes the elements of WP ada di dalam assessment tersebut.
Okey, satu soalan, kalau subjek tu subjek design kan? Maksudnya kalau dalam civil basic building design kan? Okay. Mestilah dia ada code of practice yang nak kena ikut.
Betul.
So dalam kes itu soalan akan jadi technical problem ke ataupun kita nak of course dia adalah technical problems kan? Macam mana kita nak jadikan dia complex problem sebab dia memang kena ikut procedures tu macam ni.
Okay. Yes, very good example. Macam contohnya kalau kita nak buat bangunan yang 7 tingkat kita tengah duduk ni kan. So if it is a normal situation, kita tak ada tasik, kita just a building, kita tak ada tasik sebelah kita buat building, kita ada foundation, kita ikut proses yang biasa. Tetapi apabila kita buat bangunan kita ni di atas tasik, is no longer a normal situation, kan? Kita kena ada consideration pasal airnya, pasal soilnya, maknanya problem tersebut jika dia hanya membina bangunan di atas tanah rata yang biasa saja, boleh ikut yang biasa. Itu pada pandangan saya lah. Tetapi jika kita letak bangunan yang 7 tingkat ni di atas air, so kita kena ada other consideration. It's no longer a straightforward technical problem, it becomes a complex problem. Dia kena ada faktor-faktor lain. Yang tu yang kita kata problem tersebut, technical problem, boleh ditukar kepada complex problem.
Okey. Kalau macam tu, ni dalam soalan peperiksaan akhir, kalau dalam soalan peperiksaan akhir lah, major part can be technical, but it must have one part that considered as complex. Boleh macam tu? Boleh.
Maknanya kita ada soalan tambahan, contohnya jika bangunan ini dibina pula di atas laut, apakah consideration yang perlu diguna pakai, apa pandangan pelajar. So maknanya itu is additional problem lah. Maknanya kita boleh kata yes, the question is already become a complex bila ada soalan-soalan sebegitu.
Okay, jelas. Thank you very much.
Most welcome.
Okay, Prof. So I have a couple of questions from the chat box. One is hidden, a direct message to me from hamba Allah.
Okay.
Right, dia tak nak reveal diri dia, right? So the question is, what advice can you give to all staff in preparing to ensure smooth transition from old POs EAC to new WK/WP EA? Saya pun tak berdapat tambahan.
Moderator jawablah.
Okay, smooth transition from old POs EAC to a new WK/WP EA. So I think I have to make aware lah, WK/WP EA ni dah ada dalam dokumen yang sebelum ni, right? Dia kata how can in term of practice, I think how can we ensure smooth transitions. Boleh, saya pun tak tahu nak goreng macam mana ni.
Yang ni PDA kena jawab lah. Tapi just in order to ensure a smooth transition, probably it is a cooperation of everybody. Maknanya contohnya, kalau saya buat soalan, saya prepare my assessment, the moderator pun, contohnya Dr. Yazdi, dia pun kena faham juga apakah kefahaman terhadap WK, WP, WA itu kena sama in order for him, untuk Dr. Yazdi menyemak soalan kompleks problem saya. So kalau dia tak faham, saya pula macam pura-pura faham, so dia jadi pura-pura lah semua. So this require understanding. I think initiative daripada E²IG ni very good. I think this is just a sharing session yang mana kita hanya cuba mengingatkan balik lah, maknanya transition tu kena usaha setiap individu. Maknanya baik yang lama, baik yang staff baru, semua kena terlibat sama untuk cuba memahami. It is a learning process. It's not boleh faham dengar hari ni terus boleh faham kan. So it's not straightforward lah. So it is, for me, is a cooperation of everybody in order for us to ensure the smooth transition. So it's not something new. I think benda dah ada, cuma ada perubahan sedikit. Kita punya PO dah ada sedikit perubahan, cuma it's just a consolidation of the information sajalah. Mungkin moderator ada jawapan.
Sebab in previous EAC punya document 2017, those EA and WK is already there, but the implementation is still not there yet. But I think with the 2020 documentation from the EAC, it clarifies further that it is required to make it visible in the curriculums or in the assessments. Okay, so there's another question from the then Deputy Deans of Academic, Professor Dr. Danny Ismail. So what would be the best way to prepare students in terms of teaching and learning activities for such complex in nature assessments? Dekat chat box panjang tu.
Okay.
Okey, tengok
Okay, terima kasih. So, I think Prof. Aliani boleh jawab tu. Yes, I totally agree. Situation yang disebut oleh Prof. Alia tadi, di mana lecturer use the same approach, traditional approach to prepare to lecture student, but we at the end of the day we ask the student to come up with a complex problem solution pula. So the best way is basically how to prep the student is we give examples. We provide example what are the expectation. So maknanya kita janganlah daripada test 1, test 2, assignment tak ada apa-apa complex problem, suddenly final exam keluar soalan ada complex problem. So we should prepare the student by telling them what are the expectation, how do you approach a complex problem, what are the kind of solutions, how you get marks for giving such answers. Maknanya tak boleh surprise lah, surprise element. I think I also make mistake before where we expect student boleh come up with a complex solution, which is it fails. Maknanya kita nampak student memang tak ready, because the way we teach student, kita expect student tahu semuanya. We cannot expect that. Maybe from our perspective, it is already doable. Tapi pada pandangan pelajar, it is very complex. It is no solution. So apa yang kita nak, kita kena tunjuk kat pelajar. The ways, yang paling penting expectation kita lah. So itu pandangan saya. Maybe ada pandangan daripada rakan-rakan yang lain.
Prof Rahim, kau tanya yang kompleks itu, if we put into assignments only, is it okay? Let them think in terms of assignment rather than test 1, test 2 dengan exam tu.
Okay, thank you, Dr. Wan. So yes, it is allowable to have to address the complex problem in assignments, maknanya project, it can be group assignments and so on. But the WP1, the knowledge tu boleh kita address dalam examination. But it's okay. The answer is yes, you can address the WP in assignments, in projects and so on.
Ya, tapi in terms of the EAC punya perspektif, is it a must for the complex problem to be clearly addressed in the final exam?
Okay, Prof No boleh jawab?
Boleh jawab.
Boleh jawab kan?
IG kat kita ya.
Janganlah.
Sebenarnya since 2020 they expect, dulu kita kata okay, it's hard because kalau kita tengok tadi yang Rahim tunjuk kan, apa tu criteria of complexity tu kan, 1 to 7, ada lecturer yang kata it's very hard to address in final exam, right? So those were my thinking as well before 2017, and then come 2020, WA Washington Accord expect that to happen. If you say that you are addressing PO1 to PO7, any of those, dalam exam kena ada, sebab that is the first thing they check. Kalau tak ada sebab dalam exam kena ada kena address all the PO. Once we address the PO, each problem kena ada 1+2, right? Kalau yang tu tak ada, masalah kita. Sebab that is condition for passing. Macam mana dia nak bagi condition for passing kalau dulu yang ni okay, then kalau kalau final dah okay, kalau kita lepaskan budak untuk pass, walaupun dia fail, dia tengok pula, baru dia tengok assignment, baru dia tengok test, ada tak benda-benda tu. So that is secondary. The primary is still final. You have to address your WP. Once you say that you are addressing PO1 to PO7, they have to be in the final. Kalau tak 1 soalan, 2 soalan, kalau tak 2-3 soalan, at least dalam 1 soalan mesti ada.
Okay, Prof No. Very clear.
Okay, dengar tu associate director dah sebut, kita kena buat lah kan. Itu yang contoh yang Dr. Farah bagi tadi, maknanya yang kita tambah soalan menjadikan dia kompleks. Itu pun dah cukup dah. Saying that yes, ada elemen kompleks di situ. So soalan tambahan lah, tak perlu dah the whole thing kan. Just one question addressing salah satu WP tu pun dah cantik.
Tapi that one problem kena address 1 plus 2.
Yep.
Dia tak boleh exempt to address 1 plus 1, 1 plus 1 here, 1 plus 1 tak boleh. One big problem tu kena address 1 plus 2 WP1 plus 2 others.
Means one solid problem address that 1 plus 2. Okay.
Yep.
So means we can have 1A, B, C, D kan.
Mungkin PO lain address dalam assignment, tapi at least one big problem yang kompleks.
Dia tak
Senang sikit lah kalau banyak sangat soalan ni macam tu kan.
Okay, so lagi satu ni ada from Dr. Nadia Husaini. Saya tak nampak nama dia. Ayat orang muda sikit. Boleh bagi contoh teaching delivery yang align dengan WP. Seram ni, kita coordinator IDP. Right. Ni geng-geng 90s ni.
Okay, yang ni kena tanya mama dia lah kan.
Mama dia, patut lemak dia ke? Okay, tanya mama lah.
Ampun.
Patut lah.
I think IDP
Apa, yang ni sebelum tidur nanti kena ajar.
Saya nak cadangkan untuk E²IG adakan satu lagi sesi webinar untuk IDP very important, so that kita kadang-kadang praktis dekat jabatan kami agak berbeza, mungkin ada best practice, itu cadangan lah untuk kita ada satu webinar untuk all the IDPs punya coordinator, so kita boleh share the approach and then boleh belajar antara satu sama lain lah. So untuk jawabkan panjang sangat nanti kan, boleh macam tu, ini cadangan saya. Mungkin Dr. Salah ke boleh conduct ke apa ke kan.
Yeah, we can put that thing into account lah. Nanti kita akan discuss among the E²IG punya committee and see whether we could.
Sebab ada few lagi yang tak aware dengan constructive alignment ni. Soalan Alia tadi sebenarnya constructive alignment. If you don't start with your outcomes, macam mana you nak deliver an assessment and your assessment to align kan?
Betul.
Outcome to start with and then you deliver based on that outcome and you assess based on that outcome. Kalau that happens, then your IDP is there lah.
Yep.
Dah betul lah tu.
Lepas tu ada soalan lagi from the chat box daripada ketua unit GYM fakulti. And can we have example of question and assessment of each WP and EA? Okay. And then Dr. Salah tanya, how deep is deep? Okay. Apa ni? WP ada perkataan depth of knowledge and depth of analysis. So dia kata lah macam nak ukur depth tu sebenarnya. Right.
Okay, untuk depth of knowledge, depth of analysis, how deep is deep enough? So you define the depth actually. So basically, there's no saying that this is deep enough. This is not. I think it's quite subjective to say one problem is having a depth or not depth. I think that goes back to the lecturer and the moderator themselves lah.
But I think as well, Prof, to measure as well because it depends on the cognitive levels. Yeah. Kita boleh tengok dekat situ jugalah. So in terms of the quality, either it is C4 ke C5 ke C6 ke, so we control it. Because WP is general statements.
Betul.
Statements.
And more importantly, maknanya semasa kita buat proses moderasi lah. So many cases maybe during the PKP kita hantar soalan saja without the solution. It's going to be very difficult for the moderator to say yes. This is having the depth required. Sebab dengan soalan saja you tak nampak. Even dengan soalan saja kadang-kadang nampak macam kompleks, tapi tengok solution lah. Ini je dia punya jawapan. So I think it's a cooperation of everybody lah to provide the solution so that it can be properly moderated. Saying that nak tahu depth ke tak depth, dalam ke tak dalam, susah ke tak susah, kompleks atau tidak, is based on the solution. Kadang-kadang as I said again, soalan nampak kompleks, tapi bila tengok solution rupanya tak kompleks. So yang tu agak berbahaya lah. example untuk WP apa semua ni maybe boleh dikumpul di peringkat E²IG sebagai panduan lah, so that it can be apa tu referred ke, tak tahulah macam mana nak buat. Itu
sebab kita ada dapat Dr. Salah, you have something to say about this thing? Ada tak dia? Saya rasa ada request last time macam mana Salah? Dr. Salah?
Apa dia soalan dia?
Tak, yang berkenaan dengan can we have example of question assessment of each WP and EA? Kita akan compile kan?
Kita akan ada insya-Allah dengan kumpulan soalan-soalan yang contoh problem macam tadi saya rasa Prof Rahim pun dah ada few good examples. I think any design question is already a complex problem. Design questions, we put, for example, we put certain conditions, we include technical issues, non-technical issues, future recommendations. I think for a design questions is easily complex problem lah. But I really want to bring attention to the description of the complex problem lah. Contoh macam apa saya pick I pick the WP6 lah kot sebab ada stakeholders apa semua tu kan. So if we can, when we design the question, make clear who are the stakeholders. Contoh paling senang lah, saya boleh buat satu soalan yang open-ended. I mean, jawapan dia, it can range from 60% to 80%. I'm just making up questions here. And then when we ask the students, okay, which should be the answer if you are contohnya from industrial perspective, 60% or 80%. If you are from the community perspective, is it 60%, 80%? So you could craft your questions, something like that lah. But I think as for now, I could probably the easiest one would be ni lah, WP1, WP2, range of conflicting requirements, and then the last one, WP7, the interdependence kan. The problem has many subsystems and everything. I think those are the easy ones lah. I guess I think itu je lah kot. Kalau ada soalan nanti kita maybe kita boleh buat kot a compilation of examples kan that cuts through the disciplinary. That will be great. That will be really helpful for the faculty, I think.
Right, thank you very much, Dr. Salah. So, any more last questions from the floor? Oh, soalan daripada, you can read it from the chat box. And then TNCA. Syarah, okay, berkaitan dengan keperluan solution untuk moderation final exam bagi soalan. Bukan soalan, cuma pandangan. Pandangan. Okay, pandangan daripada Profesor Iqbal berkaitan dengan kumpulan solutions untuk moderation final exam bagi soalan yang require open-ended solution. Saya berpandangan pensyarah boleh beri satu contoh solution atau boleh beri general procedure untuk jawapan yang boleh diterima sebagai skema jawapan. Okay, so itu pandangan pada Prof. I think very good idea as well. Right. Okay, any other questions or any other comments or any other pandangan from the floor before kita stop? Okay, 1, 2, and 3. Okay, any last say from you, Professor Prof Rahim?
Okay, first of all, terima kasih banyak. Thank you very much for the participation from all members, and also thank you very much to E²IG for organizing this particular session. I believe this can be continued regularly. I believe so many experience, even Prof Iqbal boleh bagi talk lepas ni dan lain-lain lah. So just a sharing session. Okay. With that, thank you. I hope that there's a request from members that would like to require for the slides. Nanti saya share dengan Dr. Yazdi so that it can be benefited to the rest. Thank you very much.